Hello, Sandeep here. Welcome to Econstruct channel. In this particular video, we are going to discuss about the earthquake engineering. Why static earthquake, dynamic earthquake, scale factor, which is one of the very important phase of the earthquake engineering, is required. Why it is basically the necessity that the scaling is required. Okay, and what is basically the static earthquake, dynamic earthquake, and modal, if impact of the modal analysis to the earthquake engineering. What is basically the earthquake engineering? What are the different parameters are there in the code? Okay, so let's dive into the subject. Now, earthquake engineering, if you see that earthquake engineering as per IS code, you will see that this is a particular equation that you will be having, which is VB bar is equal to AH into W. What is VB bar? VB bar is basically the static base shear. Alright, this is a static base shear. Bar quantity, bar means the vector. Always it is the vector. Alright, so if you see that over here, bar means this is the vector quantity. Vector means the directional, where basically specific direction is there, whether it is there in the positive x direction or the positive y direction. In the global axis, when the space frame analysis you are performing in any of the mathematical model. Alright, so the static base shear formula is equal to BB bar is equal to AH, this is the AH into W. What is AH? AH is basically the horizontal acceleration coefficient. Oops, what is this term all about? Basically, if you want to see that what is horizontal acceleration coefficient, it is some particular factor multiplied by the weight of the body. I didn't get it. So I'd like to tell you. Now let's say, for example, this is the building. It is little difficult to understand. Okay, I'll tell you that this is a person. All right. And he or she is standing on the ground, and if somebody is giving a shoulder, maybe like he's playing the football and somebody is giving the shoulder, so what happens is this acts like a earthquake. All right, so how much is this particular force acting on it? It depends upon some the weight of the neighboring person, weight of this particular person, and the impact and all actually. But when it comes to the earthquake, what happens is whenever there is a ground motion that is acting onto the structure, it is all depend some particular factor multiplied by the seismic weight of the building. What is seismic weight? This is the mass. Generally, mass is equal to 1.0 times dead load plus 0.25 times the live load, and 1.5 times 1.0 times dead load plus 0.5 times the live load. In this case, live load is less than 3. In this case, live load is greater than 3 watt kilonewton per meter square. So this is basically the mass source that you will be collecting. It means what? You take the total weight of the structure, like let's say person take this entire self weight of the person plus take the 25% of the live load. Suppose if he or she is carrying a certain laptop bag or some weight on this, so whenever earthquake force is applied on it, that particular live load, percentage of the live load will be lumped to the structure, will be prone to the structure to move it around. All right, so that is basically the seismic mass. All right, so that we basically will be applying it to the structure, that multiplied by AH. What is AH? AH is little complex formula, Z by 2 into I by R into SA by G. What is that? Z is basically the zone factor. Zone factor, if you see that this is a little wrong here, this is zone 2, zone 3, zone 4 and zone 5. There is no zone 1 here. All right, after the Killary earthquake, the first zone has been completely abolished. Point 1, the first, these are the zone factors. So if you see that what is zone factor? It is the probability factor. What does that mean? Probability means how much occurrence of the earthquake that may happen on that particular surface. Let's say if you want to construct any building in Mumbai, in Delhi, or maybe in Bangalore, is the impact of the earthquake is same? It depends upon the seismic history about the project. Let's say, for example, if you want to design a Burj Dubai in Jammu and Kashmir. Oops, why? Because almost every alternate years you will see, or maybe every year you will see that the landslides and all things are happening. Where? In those part of Himalayan ranges. You know that very long time back there was a sea, and the Indian peninsula is basically moving towards the upper side, the northern side, and that's why even today you will see that the landslides are happening during the rainy season or in general also. So that's the reason that is very earthquake prone structure, means it is very highly likely that the structure will experience the earthquake, maybe smaller one or maybe the massive one, but probability would be higher. Understood? So that is the said factor. Now importance, what is importance factor? If it is a general building, the residential building, it is hardly few people are living in that. If the population is greater than 200, I mean, this is basically the latest IS 1893 code is saying, if the population is greater than 200, you will have to go for 1.2 as the importance factor. But if my population is not 200, 190, then what? You should be taking 1.9, not 1.2. 1.19 rather. Why it is like that? Because it is proportionately you should be taking that. Okay, that kind of importance we will be giving it to that particular project. All right, 1.5. What is 1.5? These are special projects. What are the special projects? Let's say hospitals, metro projects, or you take the administrative projects, where those are very, very valuable and important projects that are, you know, given at most important. Even if the earthquake comes, you know, the economy should not get stagnant, and there shouldn't be heavy damage that will happen to the society. That's why we give the 1.5 as the importance factor to those projects. Now coming to the R value. What is R value? R is the response reduction factor. It is also known as the ductility factor. Ductility factor. What is ductility? Ductility means it whenever, let's say for example, imagine that this is a tree in Bahubali and you want to go, this is basically the tree of coconut tree, and you want to go to this fort. You remember that thing? So what he will do is he will make sure that this tree is coming like this, and through that you are going inside the fort. That twisting of the coconut tree will, imagine that instead of a coconut tree there is a RCC column. Can you do that? No, because the ductility offered by the coconut tree, which is it will be able to bend it, is totally different, totally on a very, very higher side than compared to the steel or the RCC column. That is ductility. Okay, ductile nature means it will bend, the more elastic nature and the tendency to revert back to the original situation. That is basically the ductility. More the R value, more the structure is ductile. Lesser the R value, the more the structure is rigid. Okay, so rigidity and ductility, those are completely opposite. Okay, if you want to give me the very natural example, I would like to just open, I may not sound weird, but I'll tell you that it will go inside, you know, your psychological mind, which you will not forget in any moment of time. What is the example? I still remember very long time back when I was there in Dubai, one of the Sufi saint, actually I got to know him. He was very friendly, very generous, very humble, very in a different class of person. I asked him that can you tell me some at least few basic things through which you are at this particular stage, or any suggestion for a person like me, how to live the life all about. And he has told me one weird example, and it is sticking in my heart, mind, soul, everywhere. He had just told me like this. Bah. I said, what? Okay. He said, yeah, look at this tongue. Tongue is flexible. Zindagi bhar saath mein rehti hai. It will be there throughout, you know, your life. But the teeth, because he was a little older person, there was no teeth. The teeth, ससुरे साले rigid रहते हैं, निकल जाते हैं. If the rigidity is there, actually, it will have very less amount of ductility. Whenever the forces are occurring, it will highly likely that they will go away. But the tongue, it is basically having higher amount of ductility, which will be there throughout, you know, your life. So that's the difference. Okay, I got shattered, and you know, it has really, I grabbed many things from that incident. So I thought of just sharing with you. All right, so this is basically the R value. R, there is 5, or R value is 3. R value is 5. The higher the R value, you are going from teeth to the tongue, and lesser the R value, you are going from the tongue to the teeth. All right, understood? Yeah. Okay, now let's go to the table. Actually, there is the value is 3, 4, 4.5, 5. That is maximum value that is occurring as per the Indian IS 1893 code. But if you see the other international codes, like let's say for example ACI code, UBC code, or maybe IBC codes, international codes, you will see that this value you can take it in the range of 7 or 8, 8.5 also. But why in Indian code it has not been taken to that extent? Probably we need to do a little bit more research on this. Probably. All right. Okay, so if you are planning to do some kind of PhD, I would suggest that this is the area that industry is highly likely waiting for that. All right. Another thing which is not there as per the Indian code is IMRF, intermediate moment resisting frames. It is not there. If you see the flat slab, it is on the R value. You can straight away take only 3. That's it. Whether the core is there, central core, staggered cores, or maybe different systems are there, no matter what, actually you have to go for the R value as 3 straight away. There also we need a lot of research, because if you see the IBC and UBC codes and other international codes, you will see that it's a very elaborative table. IS 1893 previous codes like 1984 or maybe the 2002 and all, actually so many lacunas was there. Thank God the revision has happened, but still a lot of revision is required, particularly in the case of R value. We definitely required a little bit longer ranges of the R value. Okay, if somebody is who is a professor or who's writing a code things and all, if they are listening, please make sure that you look at the other interest. I still remember in Dubai I used to take 5.56 R value very easily, lightly. Okay, there if you see the UBC code, 1.0 times dead load and 0.5 times the earthquake load, or maybe 1 times the earthquake load. That kind of thing is there. But when it comes to the India, we are having 1.5 times dead load plus 1.5 times the earthquake load. That is huge. Huge. You are just multiplying loads by 1.5 times higher. All right. Somebody will say that seismicity in the Dubai and many other places. If you see that, I think we should learn many things from the already developed cities, countries and all, actually, and to give a little bit leverage in certain areas so that it will not be the loss of economy as in general. If you see the Indian code, it is very conservative code. A lot of conservative code is there. First of all, you can see that 1.5 times dead load plus 1.5 times earthquake load, whereas as per UBC code, this is the clause. And many other cases, you will see that this kind of injustice is there when it comes to the codal compliances. Got it? Okay, somebody will say that, sir, yes, in India we are having shuttering issues, concrete, the steel issue, steel is not proper. We all, come on, we are having 1.5 factor of safety there, 1.15 factor of safety in steel, and 1.5 partial safety factor for the concrete. If you see that the British code 1.05 times basically for the steel. All right, so already there is a lot of leverage that where is 1.15 times and where is 1.05 times. All right, so there is a lot of leverage and very conservative designs, and end of the day it becomes very impracticable, and certain clauses they will just wipe out. Even if those are there, those will be there only on the piece of paper, or maybe on the government designs or certain specific design cases it would be respected. Otherwise it will be just thrown out of the industry. All right, so it's better that we codify that and we make sure that this kind of things we restore it. I hope that day I will see as soon as possible. Right, so that is basically the R value, the ductility table and all. The R value range as per current code, R value ranges between 3, 4, 4.55. The R value is even lesser than 3, which is for the load bearing structures, for smaller structures and all. All right, so that's about the R value. Where is the R value taken here? This is the R value taken here. So Z value we have seen, I value we have seen, and R value. Now coming back to the SA by G value, what the hell is this? Now, yes, this is one of the very important parameter, and it is also There are some guideline that we generally give it to all our students and all our consultants. What is SA by G? SA by G is the spectral acceleration with respect to the gravity. This is very important parameter. SA by G. Why not alpha, beta, gamma, omega? We are having a lot of series. If you see that in the from the 12th standard physics to the engineering, we are having many different parameters. Alpha is there, zeta is there, gamma is there, many different parameters are there. But why SA by G? SA by G is the spectral acceleration with respect to the gravity. I still remember in a long time back, one of my students said, "Sir, I didn't understand what is SA by G. I didn't understand." Many times I tried to explain him, but he said, "I completely not understood that." But on that day, thanks to that student, actually, with that virtue, I found out few things. What is that SA by G? SA by G is the spectral acceleration with respect to the gravity. What is that? It's a spectral acceleration. If you see the graph and all, actually, I'll just show you the graph also in a minute. This is the graph. Okay, it goes straight away like this. It goes straight like this, and then it jumps down like this. This is basically the Earth, and this goes to the infinity, straight. This time there is a time period. This axis and this axis, this is the SA by G. Spectral acceleration with respect to the gravity. And this is for the static analysis. In the recent code, if you see the dynamic analysis, in the static analysis, it is straight. In the dynamic analysis, yes, this is going like this, as well as it is the same graph which I am showing you on your screen. Yes, it depends upon the soil, that soft soil, medium soil, or hard soil. Okay, if the soft soil is there, then the earthquake force is little longer and all. Actually, if the hard soil is there, actually the maximum value is, it becomes shorter. What is the maximum value here at this particular junction? 2.5 times. Okay, what is spectral acceleration with respect to gravity? Now I would like to ask you one question. You can please give me the answers in the chat box. Do you think that during the event of earthquake, the gravitational acceleration force is 0? I repeat, do you think that during the event of earthquake, the gravitational acceleration offered by the Earth's surface is equal to 0? Yeah, you can give me the answer in the chat box. Yes, anybody? Answer is, it cannot be 0. If it is 0, all we will be going into the space, right? Whereas the gravitational acceleration force would be comparatively higher than its original value. How much higher is basically the SA by G in the vertical, in the lateral, and all the three-dimensional space. Basically, what is that? So during the event of earthquake, let's say for example in the class, in the classroom, for example, if so many people are just sitting and they are watching that, okay, sir is giving some kind of session here and all, actually, and one person is doing some earphones are there in his ears, and with some beat music, metal music, actually just dancing. If the sir comes there and all other people will look at him, something is wrong. Yeah, they will understand there is a music actually, but imagine that something is really wrong with this guy. Why? Because he's experiencing something else more than myself. We are experiencing the gravity, and this particular building is experiencing a little bit different than that. The entire, on the planet Earth, everybody is experiencing the gravity. When you are watching this particular video, you are also experiencing the gravity. Am I right? But at certain moment of time, some shattered things has happened actually. The experience of the gravitational force goes to very higher level due to the earthquake. And that particular factor raises bar to 2.5. That is the gravitational acceleration. Everybody got, let's say for example, I got some marks. How much percentage you will ask? Somebody will be asking that how much percentage of increment you got it, 10%, 20, 30% increment I got it in the salary or something like that. The gravitational acceleration with respect to the yardstick of the gravity. Spectral acceleration with yardstick as a gravitational acceleration. How much times? 2.5 times higher. Got it? Got it? So this is how actually the spectral acceleration, it depends upon two different parameters. One is time period, another one is the type of the soil. Type of the soil will be given by the geotechnical soil investigation report. So you need to read the report carefully. Right? Whether it is a soft soil, medium soil and hard soil. Depending upon the category and how much amount of the certain values are there, the geotechnical investigator will give you the type of the soil. Now coming to the time period. Now this is very, very interesting topic and very much misunderstood topic in the industry. One question you are having 1, 2, 3, 4, 5, 6 answers. One question you got 6 answers. So if somebody is asking what is the time period of the building, I still remember in one of the interview rounds I asked what is the time period of the building. They said that 1 year will take the building to complete it. That's not the time period. Okay, whenever anybody is asking you that what is the, if you're not understanding what is it, actually you should ask the interviewer that what is it that he's asking for. All right, so this is one lesson. Another thing is, what is time period? Time period taken by a building, let's say for example this one. Okay, what will happen? This building will go here, then it will come here, and it will come back to the original state like this over here. So time taken to complete one complete oscillation. Let's say this is the building. Okay, this is the building and it is going like this, coming like this, and it is coming right in this particular position. So you will see that the time taken by that particular building to complete one full oscillation, that is basically the time period of that particular structure. Right, so how to determine that? That's a very important question. So T is equal to 0.09 h upon square root d, T is equal to 0.075 h raised to 0.75, T is equal to 0.08 h raised to 0.75, T is equal to 0.085 h raised to 0.75, T is equal to 0.1 n, and T is equal to T tabs. Oops, one question and 6 answers. What is the real question? What is the real answer? The question is same. What is the time period of the building? Fundamental time period of the building. If there are 6 answers, actually the probable answer, the right answer is nobody knows the perfect answer. We try to, why these questions is, we try to see that it comes in a very conservative manner, that the building will not fall apart from this particular formula. Now let me tell you what is this time period. Actually we make sure that the yardstick in such a way that, okay, this is the time period, that the time period will not be more than this. The time period cannot be less than this, it would be always more than this, so that the SA by G value which I am taking, it is the optimum value. What is that all about? See, basically what is the time period is, this particular formula, the time period is for the infield wall panels, means between the 2 columns, between the shear walls and between the frames, we are having infield wall. This column, we are having infield, means some kind of partition walls like brick wall, block wall or something, not the glass wall, okay, but brick wall or block wall, something will be there. Whenever the earthquake comes, actually from here to here, whenever the earthquake comes, this particular wall will be transferring the amount of shear to the another wall. So that is the answer to this. So infield wall. So this is the most conservative formula. Then we come to the second 1.075 h raised to 0.71, that is without infield wall panels. Okay, so it means like if you go to the malls and all, you will see columns and all, and you will not see any of the infield wall. Even if there is an infield wall, it will be a glass wall. All right, so in that case we should be taking this particular formula. The another one is for the composite structures, for steel structures. This is basically for the judgment for generally 30-story building. What should be the time period? It would be in the range of 3 to 4 seconds, maximum 4.5. 5 is too much. All right, so that should be the answer. So 0.1 n. What is n? N is the number of levels. Okay, how many levels the building it is. T is equal to T tabs, means E tabs is calculating the time period for you. It is basically based on time period is directly proportional to the mass, inversely proportional to the stiffness. K is the stiffness. Okay, means the time period is more, means the building is more flexible. It is taking more time to come back to original situation. Time period is more means what? The mass is more, stiffness is less. Mass is more, but the stiffness is less. But if it is more stiff element, actually the time period will be, it will be, if you know the 12th standard physics, if you see the tuning fork, actually you'll see that certain stiffness is more, actually it will vibrate a little less. Right, you might have understood, or you might have done that experiment during that time. All right, so 1 question 6 answers. So when to use what kind of time period, I hope you got it. One time period will be given by ETABS, which is basically the program calculated time period. So if you go here, if you go to the this option, and you will see that there is an option of program calculated time period. This is the second option. Program calculated time period means the based on the fictitious force, means what will happen, the ETABS will take this particular building and will apply the unit force over here like this, and it will see that how much it is vibrating. Based on that, the ETABS will give, the software will give you the time period. That is basically the program calculated time period. Got it? Okay, so based on that we will determine this time period. Can we take this particular time period for calculating the base shear? No. Answer is big no. This is only possible for the drifts and deflections and only for the serviceability checks. Right? So all other formulas and all, if the building is based on the infill wall panels, you have to use this particular time period and all for calculating or for doing the strength design. So strength design, this formula is not at all allowed. It is allowed only for the deflections and drifts, for the serviceability checks. Okay, for strength design you should be using the different other apart from this particular formula. Understood? So far so good. Okay, so based on SA by G, what you will do is you will calculate the VB bar, which is basically the static base shear. But is it the structure that is happening? The earthquake, is it in the static form? No, it is always a dynamic. It is a big slap to the structure. Do you agree? It is a very big slap to the structure. So what happens is VB bar is the static base shear, and similarly there is a VB, it is the dynamic base shear. Now what is dynamic base shear? Let's see that. So let's say, for example, this is the project in which I have defined, this is basically the static base shear based on the static parameter IS 1893. I have defined this parameter, and similarly I'll be defining the mass source from here. So this is the mass source, 1 time the dead load and 0.25 times the live load, and based on this I'll be giving the mass source, and these are the this is the function that I have to define. This function is IS 1893. Okay, so in this particular project soil type is 2, which is the medium soil, and this particular project is there in Mumbai, so 0.16 is the zone factor. So depending upon what is 0.05? 0.05 is the damping coefficient. What is this? Yeah, so I would like to just show you the big pen. See, whenever you deal with the damping coefficient, okay, what is damp? Dampness is basically the energy absorption. What is it called as? It is nothing but the energy it will absorb the energy. Have you seen any particular building that the ground motions are happening, the building is still vibrating? Look at this building, it is vibrating since 2 years. Something is wrong with the structure, am I right? Okay. Am I right? Yes. So, for example, if any accident that has happened in your life, for example, if some accident that has happened in your life, should not happen, but I'm just giving you a hypothetical example, you will take some time to recover and you will be okay after some time, because time is basically acting it as a damping element. What is it called as? The damping element. Understood? So 5% damping is for what? 5% damping is basically for the RCC structure, 3% damping is basically for the composite structure, and 2% damping is basically for the steel structure. But nowadays in the recent code, yeah, the damping ratio you should not be taking 3% more than 3%. It means you take more damping ratio, and based on that you calculate the base shear. That's how it is. But it is still more conservative formula, but still the code is asking you to do the same. All right, so depending upon this, you will do the dynamic parameters. So you have given the spectra, response spectra. What is the response spectra? This is the response spectra. You will be defining it, and this response spectra you would be attaching it to the in the dynamic form. So if you go to the spec X, which is basically the dynamic analysis with the response spectrum, and you will give this acceleration U1. What is U1, U2, U3, R1, R2, R3? These are basically the global direction. U1, U2, U3 is what? U1, U2, U3. These are basically the forces, directive forces, directive force directions. And R1, R2, R3 are the rotational, which is moment directions. So one direction to in ETABS there is nothing called XYZ except the global axis coordinate system. We always deal with 1, 2, 3. So that's why we generally give the basic formula, which is RGB, which is a mantra. We call it as R is the red color, G is the green color, B is the blue color. RGB, not RCB, RGB. Why? Because R represents the 1 number, G represents 2 number, and B represents the 3 number. So based on that, you need to figure it out what the hell is happening to the structure. Right? Just to identify that, actually, what is this? I would like to just show you one small figure here. Look at this particular figure. X is in red color. Okay, I'll just go to the previous one. Here you can see that red color X means 1. This is 2, this is 3. All right, so these are the global axis coordinate system. Like that, there is a local axis coordinate systems are also there. Okay, I have given a separate video for that. If you really want to see that, you can just go through our channel. You will get to know what is local axis and global axis coordinate study. Okay, just to give you a figure, I would like to just show you that from here, if you just click the local axis coordinate system from here, local axis, you will see that there are some arrows coming here that are the local axis. Whereas if you see that globally over here, these are the global axis coordinate systems. All right, so if you go to the 3D part, which is basically in this case, I would like to just show you. You will see that X, Y, and Z is there in the gravitational vertical directions. All right. So if you see the forces that you are giving, it is basically the U1, U2, U3 forces. Basically U1 is the X direction, U2 is the Y direction, and U3 is the gravitational vertical direction. All right, so here you can see that in the 3D XYZ directions are there. So depending upon the color, you can determine that whether it is axis 1, 2, 3. All right, so once you have defined this spec X and spec Y in the X and Y direction, you just need to run the analysis. I already ran it. It takes hardly some 10-15 minutes just to save the time. So after that, you will run the analysis and you will see that what are the response. If you need to go to the display and story response plots. Through that, you will identify that the static base shear is coming in the range of 8,317. I think the screen is not visible for you, I guess. Okay, so it is 8,300 and here it is now 8,317. Okay, which is the static earthquake base shear. Which direction? It is in the Y direction. Understood? Okay, now let's see that EXLYP 8,300 you are getting. Just let's see that. I'll just go to the XYP. This is in the Y direction. Okay, and let's see the X direction also. This is basically the X direction. So here you can see that this is the X direction. All right, so you will get the base shear in the Y direction, which is 8,300, and we'll just see the X direction base shear also. Okay, so whenever we do that change, the software will identify that this is the graph The forces are getting transferred through the static forces on all the, this is OHT 41 level. So this is the building which we are dealing with almost 43 levels. All right, so in this particular case, 15,000 is the base shear. So 8,000 and 15,000, oops, almost double, almost double. Why it is like that? Because if you see this carefully over here, you will see that in the X direction, you will have more base dimensions at the bottom. I would like to just move this a little up so that you will get what I'm saying. Whenever you are dealing with the X direction, you will see that the maximum base, if it is connected to the Earth's surface, which is basically in the X direction, whenever the earthquake comes in the X direction, maximum time will be spent to the structure in the X direction, whereas in the Y direction, a small little wave will be there and the structure, the wave will be passed on. So that's why in the X direction, the base shear is more. Base shear is more because the D is more. In the Y direction, if you see that the D is less, that's why the base shear is less. All right, so 8,000 versus the 15,000, which you are watching it over here. Got it? Right? So now these are basically the static base shear, guys. Now we need to look at the dynamic base shear. So what is basically the dynamic base shear is saying is, if you just look into this, the VB bar and VB should be equal to 1. Okay, static and dynamic analysis. If you see that the static and dynamic analysis, you will see that the static and the dynamic analysis, the base shear need to be exactly same. What is that? VB bar is equal to VB. That is what? VB bar upon VB is equal to 1. So if the VB bar is more, generally this is the highly likely case, and VB is slightly less than this one. So what we do is we make sure, so let's say for example this is 1000, this is 500, so the scale factor will be 2. So 500 into 2, it becomes the 1000. So we make sure that VB bar and VB both are same. The static analysis and dynamic analysis base shear is going to be same. Okay, now some people will say, oh, what is this, what the hell is happening? So let's say for example, I would like to tell you one weird theory actually in this. Imagine that there is a difference between somebody is pushing you and somebody is kicking you. Am I right? Pushing you and kicking you, even if the force is same. Imagine a girl is doing like this to you and girl is giving you a slap. There is a difference. There is a huge amount of difference. Emotionally, psychologically, physically, even the distribution of forces also. Similarly to the structure also, it is not a building will not say, oh, my earthquake, like that. It's the big slap to the structure. Let it be, let's face the ground reality. Do you agree? Okay. So that's the reason. What this code is saying is, you please make sure that you calculate the base shear based on the VB bar and you distribute it as per the dynamic base shear, VB. Okay, so get the static base shear based on the static formula and distribute it as per the dynamic way. It is highly unlikely the situation that the VB will be more than the VB bar. If that is the situation, in the rarest case, till now I didn't get such kind of example. If that is the case, in that case you should be taking the VB. Why? Because always play safe. That's the rule, unwritten rule. In earthquake engineering, if you remember that one rule is sigma fx equal to sigma fy equal to sigma fz is equal to 0. That is one fundamental rule. If it is not 0, the structure will start moving in that direction. Understood? The forces will change into the work, right? So that's how it is. So VB bar is equal to VB. That's the formulation. So if you see the core on this particular building, this is basically the earthquake force. Now we will see the dynamic analysis forces also. So I'll just go to the dynamic analysis forces. I think that I have not analyzed it by now. But if you take the dynamic analysis forces, you will see that the base shear of the static and the base shear of the dynamic both should match with each other. All right. Okay, so let's say for example over here, if the earthquake, this is the static earthquake, and there is a dynamic earthquake. Let's say for example, spec X is the dynamic earthquake. So the base shear which you are getting here, 15,000, should get matched. Okay, that's based on that we will identify the scale factor and we will give this particular scaling factor. Where is the scale factor need to be given? I would like to show you. This is the scale factor. Understood? Okay, so this is how the static and dynamic analysis works. I would like to tell you that modal analysis is also encrypted inside the dynamic analysis. Why? Because this is the dynamic analysis based on the risk vectors, and if you see that the load case, which is the spec X case, you will see that the modal analysis is encrypted inside. Okay. All right, so modal analysis means any fictitious 1 kilonewton, some x kilonewton force would be given, and based on that, it's a litmus test. Based on that, we will take care of this, and based on that, we'll apply the entire base shear. This is unit force we'll be applying, and later on we'll apply the base shear. Understood? So this is how the earthquake engineering is what all about. I hope you really understood the earthquake engineering, and certain examples we need to give it a little bit weird. Generally in our master study course, which is basically 1 year course, in that particular course we will be explaining all these things. Along with that, there are many other things also we'll be explaining it to you, and based on that you please try to understand that how it works. Now regarding the master study also, I would like to show you few things. I know that it would be a little big video for you, but I would like to just show you few things, because many people have asked me this kind of things. So if you see that over here, in the master study in the structural engineering, we will explain you the finite element analysis, thin shell, thick shell, membrane, flat plate analysis, or maybe the solid analysis, solid plate, or the solid objects, brick objects, PBD, linear, non-linear, and dynamic analysis. Just now we have just saw only the dynamic analysis and the static analysis, the difference between that. Then the engineering judgment will be there, value engineering will be there, structural detailing will be there, site requirement, and certain thumb rule calculations also would be there. So that is basically the earthquake fundamentals. This is the fundamental based knowledge. Then you will have the code based knowledge. So you will be having the Indian code as well as the international code. So Indian code IS 456, IS 800, IS 875, part 1, part 2, part 3, IS 1893, IS 16700, IS 13920. International codes also will be telling you few things: BS 8110, ACI 318C, BFIP, UBC 97. In depth, we will be explaining you the different softwares like ETAS Basic, ETAS Advanced, SAFE, SAP 2000. Add-ons, we will be having the CSI Bridge, RCDC, ProCon, StatPro, and CSI Detailer. You will be dealing with RCC project, steel project, composite, PEB, shuttering design, as well as post tensions. So all these examples we will be telling you, depending upon the requirement of the job profile, you will be fitting into many different parameters. So full 1 year course will be there if you are dealing with the online. Recently we have started the offline batch also. It's a very good news for some of you who are dealing with only offline batches. Okay, so 22nd of November you need to be here in Bangalore. I would suggest you that you come one day early. So 22nd of November the batch is starting. For first 4 days it will be completely residential program. Okay, so will be there into the resort. I'll be there along with you. We will be explaining you to all the things about this, basically the ETAS basic workshop, in which many of the fundamentals also I'll be taking along with the codes. All right, so 4 days residential program would be there. So you all please pack your bags and come back over here. Hardly very less summer, because after almost two and a half years we are starting these offline batches. So hardly very limited seats are pending. So just call this particular number which is there on your screen. On the WhatsApp, do not call, please WhatsApp, and you will get all the details that you deserve to have it. All right, so see you soon. I hope you really liked the video. If you really liked it, please give the thumbs up. If you really loved it, please subscribe the channel. All right, and please come to the Bangalore to see me. 4 days there would be a bashing things. A party will be there, enjoyment will be there, food will be there. There is a swimming pool, many things, rain dance, and many outing activities also would be there. It's a very big resort. Okay, I'm sure that you would really loved it. Okay, thank you so much and see you next time. Bye bye.